Okay, so we're going to try a new method called the elimination method. And the elimination method is exactly what it sounds like. You're going to eliminate one of the two variables. In fact, the first step is the only new way to solve the problem. Steps 2 and 3 are just like the substitution method. So it's really just this first beginning part that's new. We have x plus y equals 8 and x plus 2y equals 10 for our system. We're going to look to see what has similar coefficients. So the y's, we have 2 and 1 as our coefficients. For the x, we have 1 and 1. When the coefficients are similar, that's how we know which variable to eliminate. So we're going to want to eliminate the x's in this problem. Depending on what the coefficients are, also tells you what operation to use. Essentially, we're going to add or subtract the two equations together. Okay, so let's look at this. The first thing is, I want to make sure the equations are in the same form. So notice I have the x's lined up, I have the y's lined up, I have the equal signs lined up, and then I have the constants lined up. It doesn't have to be this way, they just have to be in the same form. If it was like y plus x equals a number, as long as the other equation was y plus x equals a number, it's okay. If they were both in slope-intercept form, you could even do it. Alright, the y terms equal the x terms plus the constant. As long as they're both in the same way, we're good. So now we kind of basically have 3 problems in one. Because the coefficients here are both positive, we're going to use subtraction. It says it right here. Since both equations have an x, you can subtract one equation from another, eliminating one variable. It essentially becomes 3 subtraction problems. What is x minus x? 0x. They eliminated out of the problem. Now we have 2y minus y, because I made it into a subtraction problem. 2y minus 1y is 1y. And what is 10 minus 8? Because again, it becomes a subtraction problem. It is 2. Alright? Any questions so far?
No, sure.
Okay, cool. This is like part 1. Like, you know, I labeled the substitution 3 parts. Okay?
Yeah.
Well, guess what? Parts 2 and 3 are exactly like we did with substitution. We know our answer is going to be x comma y, right? So right now we know it's going to be something comma 2. Pick one of the equations, either the top or the bottom.
Bottom.
Or the top. Sounds like more people said the top, so we'll use that one. So x plus y equals 8, but again, it doesn't matter. Just pick one of them. Right? So we have x plus 2 equals 8. Subtract 2 from each side. We get x equals 6. So now we know that our answer should be 6 comma 2. Part 3, we just have to check. Now, because we use the top, we now have to use the
Bottom.
bottom. Good. So we have to use the x plus 2y equals 10. So we have 6 plus 2 times 2 equals 10. We have 6 plus 4 equals 10. And 10 is obviously equal to 10, which proves that we were right. It is 6 comma 2 is our answer. Okay. Now we're going to try another problem. It's a little bit different. We have 4x plus y equals 9, and 3x minus y equals 5. Okay? We see that the coefficients of x are 4 and 3, so they're different. We see that the coefficients for y are 1 and negative 1. So they're different, but they're similar, right? They're opposites. They're both 1, they're just opposites. So there's one difference between this problem and last problem. Last time, we had both positive 1 as coefficients, right? Now we have 1 and negative 1. Last time, we subtracted, right? Because we had negative 1 and, we had positive 1 and positive 1, right? So here, we have a positive 1 and a negative 1. It says y and negative y are opposites. So you can add the equations together to eliminate one of the variables. The only difference between this problem is we're going to add these two equations together. time when you're listening to the video to pause the video, try the problem, and then hit play and go back and see if you did it right. We're just going to, keep going now. You can pause in your own time. So, like I said, we're just going to add these equations. So it becomes 3 addition problems. Again, notice both equations are lined up the same way. 4x plus 3x, 7x. Y plus negative y, right? Because we're adding these two. They cancel out. Equals 9 plus 5, 14. Divide each side by 7. And x equals 2. So we know it's x comma y. Right now our answer should be 2 comma something. This was part 1. Part 2. Top or bottom, Colton?
Bottom.
Alright, so we're going to take the 3x minus y equals 5, and we're going to substitute in 2 for x. So 3 times 2 minus y equals 5. 6 minus y equals 5. Subtract 6. Subtract 6. We get negative y equals negative 1. Divide by negative 1. Divide by negative 1. Y equals 1. So our answer should be 2 comma 1. Right? We solve for x first, so we plug it into one of the equations and solve for y. Now for part 3, we're going to do our check. Again, it doesn't matter which equation you used in part 2. It matters for part 3. You have to use the opposite one. So this time we have to use the top equation of 4x plus y equals 9. Like I said, steps 2 and 3 are really the same thing you have been doing with substitution. Only part 1 is different. So 4 times 2, it says we substitute 2 in for x, plus 1 is we substitute that in for y, equals 9. 4 times 2 is 8, plus 1 is 9, and of course, 9 equals 9. It checks out. So the only difference is identifying, hey, do I need to add these equations or subtract them? When the signs are opposite, you add. When the signs are the same, you're going to end up